We often come back to these questions, so I thought this video would be useful for all of us. For me, it's a reference point, and for you, it's an opportunity to gain new knowledge and organize it somehow. So the structure of the atom in 7 minutes. So what do we know about the atom? The question of atomic structure has interested scientists for many years, and each generation of physicists had its own idea about this particle. The easiest to remember is Rutherford's standard planetary model, which you often see in textbooks. It suggests that the atom has a nucleus, and electrons revolve around the nucleus. Notice that there is not a single word about protons and neutrons. At that time, they simply didn't know about them. This model is good in every way. For a while, this model was considered optimal. Some experiments, which in fact were conducted by Rutherford himself on this topic, confirmed this logic. But later it turned out that the model was contradictory, and the contradictions lay in many parameters. The first of these is that if electrons really do orbit the nucleus just like planets do, then sooner or later they would lose their energy and start falling into the nucleus itself. As you can understand, this does not happen. Otherwise, our atoms would constantly be collapsing. When it became clear that there were contradictions, some modifications were proposed, and the most famous of these are the modifications by Niels Bohr. The Bohr model implies a certain set of, let's say, corrections to Rutherford's model. The atom begins to emit radiation only in certain cases, and in these cases, the electrons do not lose energy. And everything would be fine, but the Bohr model also failed to address many aspects, many questions that should have been clarified. For elements more complex than hydrogen, the Bohr model stopped working. Moreover, most of its principles were simply postulated. In other words, they were formulated artificially and accepted as assumptions. How can we describe strange quantum phenomena? After all, it was precisely at that time that quantum physics began to emerge. Quantum physics is interesting because, essentially, there is nothing stable, nothing clear, and all our classical mechanical analogies go out the window. It turned out that in some cases, a particle behaves very strangely. And here, quantum physics really deserves a separate lecture, so we won't go into that right now. Just remember that even the classical model, with Bohr's modifications, couldn't explain many important aspects necessary for understanding the issue. But what happened to the famous protons and neutrons in the nucleus? In fact, work was being done in parallel with what we mentioned about quantum physics. In the 1920s, Rutherford realized that the nucleus consists of protons. And in 1932, James Chadwick added to this knowledge by discovering the neutron. Since then, the atomic nucleus has been described as consisting of protons and neutrons. And here the Schrödinger model of the atom comes onto the scene. To this day, it is the most optimal model we can offer. It represents essentially the same model as Rutherford's. Inside an atom, there is a nucleus at the center of the atom, and around this nucleus are electrons. But note an important point. The electrons are not in motion there, and they are not on any orbits like planets. They are located at certain points. Does this mean that all previous knowledge has been invalidated? No, absolutely not. On the contrary, all previous knowledge has been reinforced with new additions. And it turned out that electrons are in a certain probabilistic position around the atom. The very same orbitals have been preserved, but the purpose of the orbitals implied the location of the electron and the presence of a certain amount of energy. All this knowledge also turned out to be correct. It was confirmed experimentally. At the same time, the nucleus of the atom consists of protons and neutrons. And it so happened that the electron cloud was deformed from these electrons revolving around the nucleus into a kind of probability cloud where the electron might appear. Thus, the electron became a fully quantum particle, and this quantum field existed around the atom's nucleus. This approach was able to explain a great many different contradictions, including those very contradictions we talked about earlier. The Rutherford atom model, those contradictions were, so to speak, completely eliminated or evolved into something greater. Today, the optimal model is the Schrödinger model, and the Schrödinger atom is considered the most scientifically accurate. You might ask, there are many different ideas where the atom is represented as a packet of energy, or where the atom is depicted as some kind of incomprehensible structure. As an object, or anything else? And so, regarding this rule, there are different ways to talk about it. A strictly scientific approach implies that there is an atomic nucleus which consists of nucleons, namely protons and neutrons, and around this atomic nucleus electrons are probabilistically distributed. The probability of their location means that an electron can appear at different points. Moreover, there is a non-zero probability that an electron, specifically associated with a particular nucleus, could suddenly end up on the other side of the universe. These are some of the interesting, let's say, features of quantum theory. At the same time, there are many other perspectives that essentially are not generally accepted. And modern science, modern physics, regards these as theories, as a set of additions, and as some, well, let's say hypothetical ideas. There are an incredible number of such ideas. And in those, the atom becomes simply a packet of energy, oscillations, or just about anything else. I'm not saying that all these theories are wrong, but the generally accepted theory is the one that has been designated as such, while, for example, Schrödinger's theories are considered more hypothetical. And perhaps sooner or later, what is being proposed there might suddenly become, well, let's say, the main theory, just as the theory we discussed a bit earlier has now become the main one. It turns out that there are scientific viewpoints and there are theoretical viewpoints. And now you are well aware of the scientific perspective. As for theoretical perspectives, that doesn't mean they're bad, but it does mean that all of this lacks concrete evidence, lacks any kind of support, and doesn't have a real experimental basis. At the same time, we can say that the atom has been studied quite thoroughly. And the model that exists is quite comprehensive. I believe that it will be supplemented, I believe that it will be deepened in its description of those phenomena that we do not understand today. For example, we still do not fully understand what a particle actually is. We do not understand why particles keep breaking down further, like nesting dolls and much more. We do not know, and science does not understand this either, and so perhaps the existing model will be supplemented in this way. Why is that? Because the current model allows us to describe and predict a great many processes. For example, the same goes for the hardening of metal is direct work with atoms and their movement within the material. The same goes for various types of implantation. Mutations, all sorts of different processes. Even something like painting a metal pole. All of this is knowledge about atoms. That is precisely why I believe that the existing model of the atom, namely the Schrödinger model, can rightfully be called comprehensive, sufficient, and more than objective. I hope this was useful, I hope it was interesting, and I believe that this short video will come in handy for all of us. If that's really the case, don't forget to give this video a like and subscribe if you haven't already. Watch new videos on the channel and see you next time.